step onto Christmas Island, and the air hits you first, sharp, sour, like something died there. But it isn't decay you're smelling. It's the aftermath of an invisible war. For years, swarms of crazy ants turned this island into a graveyard, their acid wiping out millions of red crabs.
When migrating red crabs march into their territory, the ants attack, squirting acid into the crabs' eyes and mouths. The crabs have no defense.
Then came a desperate plan: unleash millions of wasps to fight back. But what happened next? Did nature finally heal, or did it make it worse? Stick with us to the end to find out. The moment everything changed. Scientists returned to one of Christmas Island's largest ant supercolonies, a place that once recorded up to 700 ants per square yard, and they were stunned by what they found. Fewer than 10 ants remained where billions had thrived just 2 years earlier. An underground city that spread across 1,850 acres had collapsed into nothing but ruins. The red crabs were digging their mating burrows again in peace, right where those massive ant networks had once dominated every inch of ground. This wasn't some gradual decline that took decades. This was an immediate reaction to something released into the island's 4 worst battlegrounds in 2017. 18,000 tiny wasps, each smaller than a grain of rice, had been deployed across places called Grant's Well, Blowholes, Margaret Knoll, and Circuit Tracks. These weren't aggressive hornets that could sting or attack humans. These were parasitic wasps called Tachardiaphagus somervillei, and they had just one target programmed into their biology: the yellow lac-scale insects that were feeding the ant army. Within months of the wasp release, the ants started moving erratically. Their trails, once thick and organized like highways, began to thin out and break apart. Rangers tracking the populations noticed the ants were slower, more confused, and less aggressive than before. Something in their food supply had been cut off, and the entire supercolony was starving from the inside out. By 2019, surveys showed ant populations had crashed by 99% in treated areas. The formic acid that once made the forest floor toxic enough to blind dogs and burn human skin had nearly disappeared. The most visible proof came with the red crabs themselves. For years, their migrations had nearly vanished, their young wiped out before they could reach the sea. Now they were returning by the millions. Between 2017 and 2024, the population doubled from 40 to 50 million crabs to over 100 million, painting the island roads crimson again as entire colonies marched to the coast. The annual spectacle that once brought tourists from around the world and generated 80% of the island's tourism revenue was back, and it happened because of creatures so tiny you could fit 20 of them on the tip of a needle. But to understand how these microscopic assassins saved an entire ecosystem, we need to go back to where this nightmare began. The kingdom built by crabs. Every year in October, something happens on Christmas Island that shuts down roads, brings in tourists by the thousands, and generates 80% of the island's entire tourism revenue. Over 120 million red crabs emerge from the forest all at once and march to the sea, turning every surface crimson in a migration so massive it looks like the ground itself is moving. This isn't just a tourist spectacle. These crabs are the only thing keeping the island's entire ecosystem alive, and when they started disappearing, the forest began to suffocate. Christmas Island is basically an underwater mountain sitting 217 miles south of Java and 1,600 miles northwest of Perth, Australia. This 52-square-mile island has been isolated for over 37 million years, and that kind of separation created something special. Creatures found absolutely nowhere else on Earth evolved here. Because there were no land predators for tens of millions of years, crabs became the undisputed rulers. These red land crabs aren't just wandering around. They literally keep the island running. They cover the forest floor, eating fallen leaves, seedlings, fruits, and flowers. And while they're eating, they release nutrients back into the soil. They dig burrows all over the forest that loosen the earth and allow water to penetrate deeper. They thin out young plants before they can grow too dense and choke out the canopy. Every part of the forest depends on their constant movement, and for hundreds of thousands of years, this system worked perfectly, with every creature having its place. For most of the year, red crabs live solitary lives in those burrows they dig everywhere. During the dry season, they stay hidden underground for 2 or 3 months because crabs need high humidity to survive. When the rainy season begins in October or November, they all emerge at once for their legendary mass migration to breeding grounds on the coast. Roads get shut down to let them pass. After mating, red crab eggs hatch immediately, and the larvae live in the sea for a month before returning to land, molting into air-breathing crabs and slowly moving inland to repeat the cycle. This was harmony, nature's clock ticking without a single missed beat for millions of years. Then came an accident that would nearly destroy everything. When the invisible army landed. One underground city on this island houses 7.5 billion ants, and that's just the ones scientists spotted on the surface. The real population living in the treetops could be twice that, more than the entire human population of Earth, concentrated in a single supercolony that spreads across 1,850 acres. These weren't separate colonies fighting each other for territory. They built whole networks connected together, living as one massive organism, and they wiped out between 15 and 40 million red crabs in just a few years. No one saw them coming. Yellow crazy ants arrived as stowaways on cargo ships sometime in the first half of the 20th century, probably from Southeast Asia, though nobody knows for certain. They got their name from their erratic behavior, darting around frantically with aggression levels maxed out, attacking furiously as if fear simply doesn't exist. The island had no natural predators to keep them in check, so they spread quickly and formed something terrifying. The 1,850-acre city is more than 3 times the size of the entire Principality of Monaco, but all these measurements are approximate because it's impossible to say where one anthill ends and another begins when ants are constantly running back and forth gathering food around the clock. The density near these cities reaches over 1,000 ants per 10 square feet. Walk across that ground, and every step lands on 1,000 aggressive insects, which explains why any crab that wanders outside its burrow onto ant territory dies on the spot. Where tourists once watched hundreds of these unique creatures on their annual migration, the trails emptied and the forest floor turned silent. The tourism revenue that once thrived on the spectacle started drying up, and locals noticed something else changing too. The ants weren't just killing crabs by biting them, they had a weapon far more devastating. Before we continue, hit the like button. The acid that turned crabs to stone. When yellow crazy ants attack, they weaponize one of the most powerful acids in nature. Defending themselves or hunting prey, these ants shoot streams of formic acid directly at their target, aiming with precision for the most vulnerable spots. For a red crab, that means the eyes and leg joints. The acid burns into the joints, robbing the crab of its ability to move and completely throwing off its sense of direction. That's when the swarm closes in. Remember those 1,000 ants per 10 square feet? They pour over the blinded, paralyzed crab and tear it apart piece by piece. With this density, the formic acid can wipe out entire crab communities at once. The acid doesn't just burn on contact, it also works as a suffocating toxic gas that spreads through underground burrows. Any other crabs hiding nearby die too, usually within just 24 hours of exposure. The scene gets so horrifying that even dogs can go blind if they wander into an ant zone, and human skin burns on contact with the acid spray. Once a crab dies, the ants don't waste the real estate. The crab's burrows get used as nurseries for the ants' offspring, with queens laying eggs right among the remains of the previous tenant. In areas where the ant cities are truly massive, they can silence an entire stretch of forest, leaving nothing living there. The loss of the crabs sent shockwaves rippling through the island. Without them clearing fallen leaves, the forest floor became buried under rotting vegetation. Leaves piled up everywhere on the ground, which affected humidity, temperature, and nutrient cycles. This led to the growth of lots of seedlings that formed dense undergrowth. Young trees grew too densely, suffocating the mature forest. Fires burned hotter and more intensely with all that dry fuel. Invasive giant African snails moved in, feeding on the decay. The sweet liquid dropped by another species encouraged thick, black, sooty mold growth that suppresses photosynthesis, slowly killing the trees from the canopy down. And the ants had helped maintaining this destruction. The secret alliance that fed the empire. Huge ant cities can't survive without a steady food source, and that supply came from another non-native species that humans once praised as a golden resource, the yellow lac-scale insect, a tiny bug that sucks sap from trees and secretes a sweet substance called honeydew. Humans once extracted shellac from this very insect, a rare natural resin used to make vinyl records, fine lacquer, and classical musical instruments. But on Christmas Island, what was once a resource had turned into a biological weapon. The ants harvest this honeydew because it's packed with carbohydrates, and that's how their colonies survive and keep growing in size. In return, the ants protect the scale insects just like farmers guard their livestock, driving away any natural predators that might threaten their food supply. This mutually beneficial relationship helped both invasive species spread with frightening speed. Research found that yellow crazy ant populations increased by as much as 95% when yellow lac scales were present, a terrifying rate of expansion, like pouring gasoline onto an already burning fire. One large field experiment proved just how dependent the ants were. When scientists cut ants off from the yellow lac scale insects, their activity on the ground dropped by 95% in just 4 weeks. It makes sense because it's hard to stay active when you're starving. As for these scale insects, they might depend on the ants just as much as the ants depend on them, since without ant protection, their natural enemies would keep them in check. Even without ants, yellow lac scale insects cause serious damage. If their numbers get too high, they can make even really large trees dry out and die, basically acting as tree vampires. When they number in the hundreds of thousands, the stress makes trees start losing their leaves. If that stress continues season after season, it kills them. The sweet liquid they drop onto branches encourages mold growth, and that mold suppresses photosynthesis, leading to the same result. The tree dies, and the mold changes soil structure, helping other non-native species move into areas controlled by ant cities. Scientists realized that breaking this partnership was the key to stopping the ants. But to stop the ants for real, they had to do more. I know you're poised to know what happened next. Before we continue, share this with a friend who you think may be curious to know. The poison from the sky. The first weapon scientists tried was poisoned bait, a program that started back in 2001. The product was called Antoff, wrapped in protein granules with a fragrant coating that ants found irresistible. Inside that tasty meal was fipronil, a broad-spectrum neurotoxin that attacks the nervous system of any animal without a spine. The plan seemed clever: trick the ants into carrying poison home to their queens and collapse the colony from within. Rangers had to walk straight into the middle of ant cities, surrounded by billions of crawling insects, scattering the bait by hand while wearing full protective suits because the formic acid was spraying from every direction. They trekked for hours through seas of ants where one wrong step could mean blistered skin. Luckily, 3 times a helicopter came to the island to drop bait from the air, with a density of about 6 pounds per acre that reduced ant populations by over 90%. The critical challenge was timing. The bait could only be used during the dry season when red crabs stay in their burrows because crabs need high humidity. And when the weather's dry, not even delicious granules can lure them out. A single mistake in timing, if the bait was laid during the crab's migration period, would turn the island's heroes into victims. The red crabs would eat the poison bait and die in massive numbers, creating the painful paradox of saving the ecosystem by killing the very creatures that protect it. For a few weeks after each treatment, it looked like victory, but only a few months later, from untouched corners of the forest and deep ravines where helicopters couldn't reach, the ants came back stronger than ever, as if they had never been defeated. In just a few years, new colonies spring up, and you have to start all over again. Each large-scale baiting campaign costs between $1.3 and $2 million, not including manpower, helicopters, and equipment. Worse still, fipronil couldn't tell friend from foe, poisoning many native insects and disrupting the food chain. The poison was incredibly expensive, yet far from effective, like mowing weeds without pulling out the roots. When chemicals failed, scientists turned to something alive, something that could infiltrate the enemy from the inside. The assassin that kills from within. Unlike ants, yellow lac scale insects can actually be managed biologically. Classic biological control is based on a simple idea. In nature, every species is kept in check by its enemies, like predators, parasites, or diseases. When an organism becomes invasive, scientists look for its natural enemy in its homeland and bring it to the place where the species has gone out of control, trying to restore the natural balance. Scientists started searching for a species that could control the yellow lac scale insects on Christmas Island, and they actually found one. The archenemy of the scale insects turned out to be a tiny wasp, known as Tachydiaphagus somervillei. This wasp keeps the scale insects in check in its native Southeast Asia through a mechanism that sounds chilling. Each female wasp searches for a lac scale, lays an egg inside its body, and the larvae then consume the host from within, until nothing is left but an empty shell. New wasps emerge, and the cycle starts over again. The wasp, working together with other predators, is so effective that lac insects are rarely seen in their native range. This species is really tiny, about 0.08 inches long, and it can't even sting. It doesn't build nests either, and causes no harm to humans, other animals, or plants. In short, it has just one clear goal: to find a scale insect and continue its line through it. Each wasp can lay up to 8 eggs in a single female and can parasitize over 150 scale insects in its lifetime. Ironically, this species is considered a pest in the shellac industry of India and Thailand, where producers curse the wasp for destroying their resin crops. But Australia had learned hard lessons about introducing non-native species. The cane toads brought in during the 1930s to eat beetles became a venomous plague. The mongooses imported to Hawaii to kill rats ended up wiping out birds instead because mongooses are active during the day, while rats are active at night. In both cases, these species were brought in without sufficient research, and each so-called fix unleashed chaos worse than the original problem. This time would be different. The Australian Department of Agriculture has strict rules for conducting scientific research, and this project would become the most thoroughly researched biological control program in the nation's history. The question was, how many years of testing would be enough to guarantee the wasps wouldn't become the next disaster? 3 years of testing before the gamble. Researchers from La Trobe University in Perth, Australia, took the lead on what they called the Crab Rescue Project. Under their supervision, 300 tiny wasps were brought in from Malaysia in 2014. Over the next 3 years, the project participants bred the wasps in contained laboratory environments until their numbers reached several thousand, but the breeding program was only half the work. The other half was proving these wasps wouldn't attack anything except their intended target. Scientists carried out extensive studies to find out whether the wasp attacks other species. In Malaysia, right in the field, researchers released the wasps onto 8 closely related scale insects, and none of them were harmed. This proved that no other population of scale insects on Christmas Island would be at risk. The team tested 131 native species in total to make sure the wasps had no interest in anything beyond the yellow lac scales. The researchers also checked that the wasps stay active even when yellow crazy ants are taking care of the scale insects. In other words, the wasp killers don't care if there are bodyguards or not. They attack anyway, which was crucial because the ants aggressively protect their food source and drive away most predators. People carefully studied the possible negative effects of introducing the wasps and tried to minimize every risk they could identify. By 2016, after 3 years of exhaustive testing, the government gave the green light. The scientists called it the most thoroughly researched biological control project in Australian history, specifically designed to avoid repeating the disasters of cane toads and mongooses. Still, there was no way to be completely certain until the wasps were released into the wild ecosystem. The deployment strategy was surgical. 18,000 wasps would be released across the island's 4 worst infestations: Grants Well, Blowholes, Margaret Knoll, and Circuit Tracks. Half of them would be sent straight to the front lines, released directly onto the ant territories. The remaining wasps would be placed in special greenhouses where they grew plants that scale insects particularly love, then infected those plants and released the wasps once they had both food and a cozy nursery for raising their young. Helicopters loaded with containers of microscopic wasps took off in 2017, flying low over the dense canopy. The hatches opened, and the invisible army poured out over the island's most devastated zones. Then came the waiting. The comeback nobody expected. For about 2 years since the wasps were released, the team monitored the crazy ant population in different parts of the island. The wasps had vanished into the forest like vapor after deployment, and for months, there were no dramatic visible changes, no explosions, no massive die-offs that you could see from the air. But inside the trees where scale insects clung to branches, something was happening. The wasps were laying eggs, and the parasites were rotting the scales from within. Honeydew flows slowed down. Ants that once moved in organized highways started behaving erratically, confused and hungry. The carbohydrate supply that fueled their reproduction and aggression was disappearing, and the entire supercolony started collapsing from starvation. Rangers recorded the first signs of hesitation in trails that once looked unstoppable. Then those trails began to thin out and break apart entirely. By 2019, the results were very encouraging. In some areas, the enemy's ranks had really thinned out. At least in one spot, surveys showed that out of 700 ants in the study area, only 10 were left. This allowed the crabs to dig their mating burrows in peace, right where an underground ant city had once dominated. Ant populations had dropped by 90% in treated areas, and in some zones, the crash reached 99%. The most visible proof came with the red crab migration. Since the arrival of the micro-wasp in 2017, the annual red crab migration for mating had grown massive. At first, the number of adult crabs migrating was about 40 to 50 million. But by 2024, it had reached 100 million, a stunning comeback that doubled the population in just a few rainy seasons. The spectacle that once brought tourists from around the world and generated 80% of the island's tourism revenue was back in full force. The ecosystem followed suit. Fallen leaves that once piled high and rotted into wildfire traps disappeared, proving that the forest's nutrient recycling cycle had come back to life. Forest patches once choked by thick black sooty mold were slowly turning green again. Even the rare endemic bird, Abbott's booby, which had been in severe decline due to dying trees and lost nesting sites, escaped the path to extinction. But the scientists didn't rush to declare total victory. The war that never ends. There was still no time to rest because the ant problem remained very real, and it's all because the location is so isolated. Just like on many oceanic islands worldwide, Christmas Island has, over millions of years, produced unique creatures, a special set of organisms including plants, birds, mammals, fish, reptiles, and insects, and they're still under threat. There are more than 20 species of land crabs on the island, and the ants don't discriminate. The ant size doesn't lessen the damage they do because these tiny insects can gather into huge colonies, killing much larger animals. Among their victims are lizards, frogs, small mammals, baby turtles, and chicks. In areas where the ant cities are truly massive, they can silence an entire stretch of forest. Deep in the island's interior, particularly in jungle ravines and steep valleys where helicopters couldn't reach, ant pockets still exist. These untreated zones remain ready to explode back across the island with the next monsoon season. Even after deploying the parasitic wasp operation and numerous chemical measures, yellow crazy ants still hold control over many remote forest regions. That's why in 2021, scientists announced they might use another biological control method. Now they want to bring in an African micro-wasp that could attack scales many times more aggressively and potentially finish the job. But here's the problem. For Australian agriculture, this new wasp is considered a pest. If these wasps were ever to escape containment, would Australia's agriculture have to pay the ultimate price? This is no longer just a biological challenge. It's an ethical gamble where every decision carries the weight of an entire ecosystem. Scientists warn that just one wrong decision could erase 110 million years of evolution, something that no place on Earth could ever recreate. So far, the go-ahead for the new killer wasp is only on paper, plus it needs extensive additional research. The question now isn't how to win, but how much humanity is willing to risk. Maybe saving the red crabs and the 20 other endemic species found nowhere else is worth taking that risk, or maybe holding the line with the current wasp population is the wiser choice. One small mistake in introducing non-native species nearly destroyed this island. Another mistake, trying to fix it, could finish the job, or it could save one of Earth's most unique ecosystems forever. The reaction to the first wasp release was immediate and miraculous, but the final chapter of Christmas Island's story hasn't been written yet. Subscribe and turn on notifications so you don't miss what comes next. Thanks for watching. See you in the next one.